This is Unit 3, Lesson 6. We're going to talk about more factoring. I'm just going to go through a few examples here together. We have already done a couple of types of factoring. We have factored simple trinomials, and we have factored difference of squares. We know that A is a simple trinomial because it has an x squared, an x, and a number. And to come up with the factors for my simple trinomial, I will have two sets of brackets, an x at the front of each one that would multiply to give me x squared. And then I have to figure out the numbers that go in the bracket by figuring out what multiplies to -24, and those same numbers have to add up to 5. So the numbers that multiply to -4 and add up to 5 would be +8 and -3. So there's our factors. I know this one's a difference of squares because both terms are perfect squares. I have an x squared, and I can do the square root of 49. And it's subtracting. Subtracting means it's a difference. To get my factors here, I put my two brackets. I have x at the front, and the square root of 49 is 7. And they're the exact same factors, except one is plus and one is minus. D also is a simple trinomial, which is easy to tell because it has an x squared, an x, and a number. So we have our two brackets, an x at the front, and now I need to know what multiplies to 32 and adds up to -12. So we'd have -8 and -4. This one in C does not look like a difference of squares because there's no subtracting, nor does it look like a simple trinomial because it's got an x squared and an x but no number. But you can think of it as being +0. So I could multiply it or come up with my factors the same way as a trinomial. X, x, and what multiplies to get 0 and adds up to 8? Well, that would be 0 and 8. But in math, we don't like to write more than we have to. So x plus 0 does not change anything. So it's really just x, bracket, x plus 8. So we're going to move on today with something called common factor. A common factor is a number of a term that divides evenly into each term of an expression or a polynomial. So there's basically 4 steps. We have to figure out the GCF, the greatest common factor. That is the biggest number, letter, or number and letter that all the terms divide by. We write that down, we make a bracket, and we divide them each by the greatest common factor. So in A, 3x and 18. 3 and 18 both divide by 3. That's it. Since 18 has no x, x is not common to both terms. So the greatest common factor is 3. So I write it down, I put a bracket, and mathematically what I'm doing is dividing both terms by the greatest common factor. So 3 divided by 3 would be 1x, and 18 divided by 3 would be 6. And the idea here is, if I were to remove my brackets, I would get the answer I started with, because 3 times x is 3x, and 3 times 6 is 18, what I started with. So if I look at another example, 8x and 20. X is not common to both, so there's no letter in the common factor. For 8 and 20, they both divide by 2, but that's not the greatest number they both divide by. The greatest number they both divide by is 4. So now I'm going to divide them both by 4. So I have 2x plus 5. And the excellent part about this is you can always check your answer. Oh, there goes the PA. I guess you'll hear the announcement. So 4 times 2 would be 8x, and 4 times 5 would be 20, so I know I'm right. Last one. Look at my terms. This time, there is an x in both terms. This one has an x squared, and this one has an x. So the common factor for letters, the greatest common factor is always the lowest exponent. So I have an x squared and an x. The greatest common factor will be x, because the lowest exponent is 1. Then I do my numbers. I have a 5 and I have a 20. So the greatest common factor for 5 and 20 is 5. So I'm going to divide both terms by 5x. So 5 divided by 5 is 1. When I divide letters, I subtract their exponents. So this x on the bottom and x squared on the top. 2 take away 1 would mean I'd have an x left. And then I divide my numbers. 20 divided by 5 is 4. And 1 take away 1 would mean I'd have 0, x to the 0. So no x's. And we can always check. 5x times x is 5x squared. And 5x times 4 is 20x. So we're good. Common factoring. Get the greatest common factor, divide by it, and write down your answer in brackets. So you should stop the video, do page 233, number 13. Now that you've done page 233, number 13, we're going to go back and look at some more difficult factoring. We've looked at simple trinomials. We're going to talk about some difficult trinomials. Difficult trinomials happen when the number in front of the x squared is something other than 1. So 2 or 3 or 6 or 8 or 10, something other than 1 in front of the x squared. When that happens, we want to common factor it first and then factor it again using what we know about trinomials. So if I look at A, the number in front of the x squared is a 3. It just so happens 15 and 12 both divide by 3. So it is a common factor. So I'm going to divide each one by 3. That would leave x squared, that would leave 5x, and that would leave 4. You'll notice this time I didn't write out that I was what I was dividing. You don't have to write that step. You can do that step in your head, the dividing part. You don't have to write it out. Now I notice that I've got my trinomial. I want to factor again, get numbers that multiply to 4 and add up to 5. So I keep my greatest common factor, and to factor a trinomial I have 2 brackets, an x at the front of each, and what multiplies to 4 and adds to 5 would be plus 4 and plus 1. The order doesn't matter. I could have put plus 1 first and then plus 4. Let's do these ones quick. So same deal, 4 at the front. Oh, they all divide by 4. So I'm going to divide them all by 4. It leaves me x squared plus 3x. 72 divided by 4. Brain freeze, 13, I believe. 4 3s are 12, carry the 1, 4, 5, definitely not 13. Did that wrong in my head. 4 goes into 7 once. That leaves 32, 18. Let me double check that in my brain this time. 32, carry the 30, yep, much better. So I divided everything by 4. Now I can see that I'm left with a trinomial in the bracket. X squared, x, and a number. I want to find out what multiplies to negative 18 and adds up to 3. So I keep my common factor, my 2 sets of brackets. Multiplies to negative 18 and adds up to 3 would be plus 6 and minus 3. And it might take you a little bit longer to come up with those numbers. That's okay. The better you are with your multiplication tables, the easier factoring will be. Next one, -2 in front. So I'm going to divide everything by -2. Watch when you're dividing by a negative that your signs will change. So when I divided everything by -2, I got x squared. 2 divided by -2 is -1. And 42 divided by -2 is -21. And there's that trinomial again. Put my two brackets. And what multiplies to get -21 and adds up to get -1? Well, the only things that multiply to get 21 is 7 and 3. And they're not going to add up to -1. So that means that the simple trinomial does not factor. So that means that I'm done. There's no more factoring to happen. That's all I can factor because the trinomial doesn't factor anymore. Last one. You see a 5 in front. I'm going to divide everything by 5. So that leaves x squared. 5 goes into 80 once. 8 once. 50 goes into 8 once. Leaves a 3. That'd be 16. This time I don't have a trinomial left, but I have a difference of squares because I can square root 16 and I have a negative. So I keep going with my factoring. Keep my 5 and I factor my difference of squares. Square root of 16 is 4. So I have -4 and +4. So our job here, if there's a number in front of the x squared other than 1, you need to common factor it. Divide everything by that number. And then see if you can factor some more. Factoring by simple trinomial or factoring by difference of squares. Okay, page 259. Try those out. Let me know if you have any problems.